Okay, so today we're going to talk about squaring binomials. Here's the first mistake most students will make squaring these things. Most students will go, oh, I'm going to square this? I'm going to just distribute this to everything on the inside. The reason that's a mistake is this time, the reason we can't do that like last chapter is because our signs have changed. If you look, in the first chapter, everything was multiplication. In this chapter with polynomials, we have a big issue, which is this plus sign. This plus sign changes everything. That means that the operation I have to do first is I have to square this. So I don't get the distribution process, but the nice part is I can actually square this. Square this just means multiply it by itself. So that's all we're going to do, is we're going to multiply this thing by itself. Now that we have that, this looks like what we did on Friday with the double distribute stuff. So we could go, oh, I'm going to cover up the 5, I'm going to take the 2x, and I'm going to distribute it across. So I would get 4x squared plus 10x. Now I'm going to do the same thing. I'm going to pretend like the 2x isn't there, and I'm going to distribute the 5, which I would get 10x plus 25. And now we just combined the like terms here in the middle. Which, if we write this all out again, would be 4x squared plus 20x plus 25. And that would be it. Let's try a second one. Again, we're going to square this binomial. We can't distribute this 2 because of the minus sign. So we're just going to rewrite what this means, which is 3x minus 5 times 3x minus 5. We're now going to distribute. So I'm going to distribute the 3x to both these terms. I'm going to get 9x squared minus 15x. We're now going to go through and distribute the negative 5, which is going to give me negative 15x plus 25. This is going to end up giving me, because we have 4 terms, but we got to combine the 2 middle ones, 9x squared minus 30x plus 25. And again, this would be my final answer. Okay. For the squaring thing, again, the biggest thing that you need to remember to do is you can't distribute this 2. You got to rewrite it out and times it by itself. Let's do one last example. In this example, we're going to look at a binomial times a trinomial and see what will happen. So here's my binomial. I have 2x minus 5, and my trinomial is 4x squared minus 2x plus 7. We're going to distribute this 2x and kind of see what is going to happen. So we first start out by distributing the 2x. This would give me 8x to the third minus 4x squared plus 14. Now that we've distributed the 2x, we have to distribute this negative 5. So then I would get negative 20x squared plus 10x minus 35. Over here, with this 2x, I just realized I made a small mistake. That 2x times the 7x should have given me 14x. So I just went back and fixed that real quick. Now that we have this part, we're just going to combine our like terms. So the x to the third doesn't have any more x to the thirds. This negative 4x squared does match with this negative 20x squared because they both have these x squareds on the end. So that's going to give me negative 24x squared. This 14x will now match with this 10x, which will give me, plus 24x. And then this negative 35 doesn't have anything combined. So this would be my final answer. For any of the distributing things that get more and more terms, I could actually have another term out here, and then you just would distribute that, and then distribute that, and distribute that. With a binomial times a trinomial, you get 6 terms. And that should make sense because you'll distribute 3, and then another 3, so that makes 6. With things bigger than that, you can get more and more terms, like a 3 term and a 3 term, or trinomial times a trinomial. You'll have 9 little things, because 3 and like 3 times 3. So the good way to check to see how many terms you should end up with is the number of terms in this one times the number of terms in that should be the number of terms you end up with. And then once you simplify, you could get less terms than that. Try the different examples today.